Well, good morning. As I was setting up, Gregor asked if I was going to be showing highlights from yesterday's game, and I explained that's probably not the best way for me to endear myself to this crowd this morning, so I think we'll refrain from any commentary. But I will say at least you qualified, all right? So you got that going for you. You know, some of us didn't have that, I guess, so such is life for another cycle. Well, let's talk about something more fun than licking our wounds over soccer losses. This cloud thing, turns out there's a lot of options. You know, you ask people, what is the cloud? And you're probably going to get 10 or 15 different answers. You know, some people, when we say cloud, they think, oh, we're talking about microservices. Or other people are like, no, we're doing modular monoliths because microservices hurt in various ways. And of course, I run into a lot of people that are very, very excited about containers. Oh, we're going to put everything in a Docker container, and that's going to solve every problem we've ever had. And of course, now things have turned, and we're talking about serverless. You know, we don't last real long with any buzzword in our industry. It seems like everything gets a certain period and then we move on to something else. You know, we were just kind of chasing after the latest shiny new thing. And of course, a lot of people are very excited about the idea of functions. And of course, everything these days has as a service at the end of it. You know, so functions as a service, FaaS, everyone's very excited about that. I actually had someone say to me a while ago that I'm an architect as a service. And I thought that was kind of cool until I actually sounded out that acronym. And then I went, wait a minute, I don't think that's quite as positive as I originally thought it was. You know, maybe that was one of those backhanded compliments. And so I know a lot of people are getting very excited about functions and serverless, and then I run into other people who are like, but I just spent all this time, effort, and energy refactoring our legacy, or as someone corrected me recently, they said, we don't have legacy code, we have heritage code. You know, trying to be a little more positive about these investments we've made in the past. You know, and so I don't want to take and reduplicate all that effort that took me to refactor everything to this microservice nirvana, and now you're telling me I need to refactor all of that to functions and serverless, and you know, that just makes me grumpy. I don't want to do that. Now maybe you're more old school, and maybe instead of this particular emoji, you think about this one. This is one of my favorites. My wife saw me putting this deck together, and she said, "What is that?" I said, "It's table flip." She said, "Table flip?" I said, "Yeah, see, he's got his arms up in the air, the table's upside down." She just shook her head and said, "I have no idea what it is you do for a living." I said, "That's okay." So please don't throw that code away quite yet. We can actually leverage a lot of that hard-earned knowledge and use that moving forward. And the message that I have really been trying to hammer on over the last few years is we as technologists have to view all of these things as nothing more than tools. They're just tools that are designed to solve a specific problem. The real challenge for us is knowing when do I pick up which of these tools to solve this particular problem. All right? I'm a software guy. I don't really know that much about hardware. And so that translates into my real world too, because at home, I'm not that good of a fix-it guy around the house. I'm not particularly handy. You know, I have one hammer because that's good enough for what I am going to attempt to do. Now, if I were to have a carpenter come out to my house to do some work, that person's going to show up with a truck full of hammers. And hopefully so. Because let's be honest, if somebody comes out to do some work and they say, this is the one hammer I use for everything, whether it's tearing down a wall, whether it's putting up shingles, whether it's doing finishing work, I just use this one hammer, you'd probably ask them to leave. You know, I've got a friend that's a woodworker, and he's got seemingly a garage full of hammers that, to my untrained eye, all look about the same. You know, but he knows exactly when to pick up which one. That's the challenge for us, is looking at all these different technology choices, all these different patterns, all these different approaches we can take, and picking out, for this particular problem, this is the right solution. You know, we need to get off of this idea that these are all or questions and realize that they're really and questions. You know, you will use containers and platforms and functions. You know, this idea that I'm going to refactor my entire application to a series of functions, probably not going to happen. Are there certain aspects of your application that lend themselves very, very well to functions? Absolutely. You know, but if you think the right answer is just to function all the things, that's not going to work. You know, if you thought it was difficult to manage 15 or 20 or 50 or 100 microservices, just wait to see what happens when you have several hundred or 1,000 functions that you're trying to manage. So the challenge for us, the message that I've been trying to get across to anybody that'll listen to me, is that we need to know when to pick up which tool. When do we use this? When do we use that? So why would we even do serverless in the first place? Well, first and foremost, I do need to emphasize there are still servers. So this is one of those really bad names we came up with. Turns out naming things is hard. It's a challenge to come up with the correct name, or as my manager put it once, who wants to argue with me about the definition of made-up words? There's a lot to be said for that in our industry. The advantage for us in this serverless environment is that we are abstracted away from those servers more so than we are in the current world. Now, I've been doing this a long time, and I remember when we basically handcrafted servers. We basically ordered the chips, put them together ourselves. There was a lot of care and feeding that went into it. These were very artisanal, bespoke servers. And that worked at the time because we didn't have a choice. And then you fast forward to today, one of the biggest leaps forward that I've seen is the fact that we don't have to go through all that pain that goes along with the care and feeding of these bespoke servers anymore. And so serverless really takes this to the extreme of you don't need to deal with provisioning. You don't need to deal with updating. You don't need to deal with scaling. That's all handled by that underlying platform. Or in other words, it's someone else's problems to solve, not yours. Now, it is important to understand that all these layers still exist. And that's why I really appreciate this tweet from Sam Newman earlier this year where he said, I was creating this slide and I realized that we've kind of made things worse, haven't we? Because now we have all these different layers that we're responsible for patching. And he's absolutely right. There's a lot more moving parts here. There's a lot more places where things can break. But that actually prompted a tweet from my colleague Josh who said, well, hang on a second here. This is why we have platforms like Cloud Foundry. This is why we have the public cloud providers. They take care of those problems for us, freeing us to focus on the stuff that really matters. And that's an important thing for us to think about. I was talking with another one of my colleagues this morning about this. To me, this is a really important part of this for us is I want to be able to focus on just working on business problems, solving business problems, not dealing with the care and feeding of all these underlying platforms. And that's an important part of this. Where do I get value? Where do I deliver value in my organization? Now, architecturally, it's important to understand what this is all built on. And there's still hardware there. There's always hardware. It's just a matter of who's actually building it. And so on top of that, we build these IaaS layers. And I remember when this was a pretty big leap forward, to be honest with you. Because now infrastructure could be spun up in a matter of days, hours, instead of what it used to be. And again, I've been doing this a long time. And I remember one instance in particular, we asked for a development server, a development database. So it was never going to have a whole lot of data in it. It took us a year to get that server created and provisioned. That's ridiculous. I still to this day have no idea how it could possibly take a year to get a development database put into place. And then with technologies like IaaS, the fact that I could basically run a script and these things would be created, that was definitely a huge step forward. But we've built upon those abstractions as well. And so the first big step here was containers. And with the container environment, I bring a container to the picture. The container has my application inside it as well as everything that my application needs to run. And then that container platform is responsible for the scheduling, giving me networking, routing, logging, all that kind of fun stuff. And that turns out to be a pretty useful abstraction for a number of applications. Not all, but many. Now, the next layer up from that would be a full-on platform, like Cloud Foundry. And the container gets provided for me. I just say I'd like to deploy a Java app or a static app or whatever it happens to be, and the container figures out, or the platform figures out what kind of container that needs. And all I have to bring to this particular party is an application. I can just focus on solving business problems, dealing with the business code, and let the platform take care of the rest. And then the container or the platform gives me images, gives me networking, gives me logs, metrics, marketplace usage, all that kind of fun stuff. Now, serverless builds on top of that and says, all right, well, we're also going to provide the container. You could even argue it's bringing the application to bear. All I need to worry about is my function. And this might be 5, 10, 15 lines of code, and that's it. That's all I'm responsible for as the developer. The platform is responsible for executing that function, scaling that function, dealing with the events that are streaming in, all that kind of fun stuff. Now, the only real difference between these is fundamentally what I'm responsible for as a developer versus the things that the tool provides for me. And the thing that I really want to emphasize here is that depending on your use case, depending on what it is you're trying to solve, different answers are going to fit in different buckets. There's no way you're going to solve every single problem with a function. You shouldn't solve every single problem with a container. The challenge for us is figuring out what goes in which of these buckets. When should I use this tool? When should I use that tool? They are all fundamentally just different layers of abstraction. And so another way of thinking about this is sort of this layer cake model that we like to use. So you still got hardware. Hardware is always going to be there. We build IaaS on top of that. We build containers on top of that. We build platforms on top of that. And then serverless, at least right now, sits at the top of that particular tree. Now, the further down we go in terms of abstraction, the more flexibility we have. If I need to define specific ports, if I need specific kinds of hardware to run very specialized things, I'm going to have to do that at that very low level. Now, there's also a lot fewer standards, there's a lot more moving parts, there's a lot more for me to maintain and manage over time. The higher up that abstraction tree I go, the easier it is, the less complexity I'm dealing with as a developer. I get more operational efficiency, because instead of this bespoke hardware environment, I just have these platforms, or I have these containers, or I have this serverless environment where, again, typically I'm not doing a heck of a lot from an operations standpoint. That turns out to be very powerful. Now, I'm sort of penned in a little bit. I don't have as much flexibility as a developer as I go up the stack. I can't define this is the port I need to be on. I might have certain resource constraints in terms of how much memory I can use, things like that. But it also means I have less to deal with. I just push my function, I push my app, and then the container takes care of the rest. That platform takes care of the rest. Now, I'm very much of the opinion that we want to push as many workloads as we can up the stack as possible, because that allows us to focus on delivering business value. At the end of the day, that's why we get paid, is to help someone solve a business problem. All this operational stuff at the bottom, that, while very important, is not something our customers typically care about. I think about how much of my career I've spent on currency issues, dealing with upgrading an operating system from this version to that version, upgrading this library from this version to that version. And again, critically important stuff for us to do, but not typically something that our customers get really excited about. Customers typically don't bake us a cake because we upgraded from version this to version that. Now, there are some people today who argue that FaaS or serverless is the new PaaS. This is, again, where we get into some debates about terminology. What does this term actually mean? There are just a veritable plethora of options here. Lambda was what first kind of got the party started. That's still what a lot of people think about when it comes to functions, but all the major public providers have their own variant here as well. There are several open source versions. I'll talk to you guys a bit about RIF here this morning. And I will admit, this very much suffers from the shiny new thing curse in our industry. We have a tendency to act an awful lot like, a dog that sees a squirrel, and we're like, ooh, chase after that one. Then, ooh, another squirrel, and we chase after that one. We're always kind of flitting from thing to thing. And so there is a lot of that here. And I've seen a lot of people get very excited about this because, they read a white paper, or they saw a tweet, or they saw some post somewhere, and they're like, oh, this company, solved the problem with serverless. We should do everything on serverless. That may work for you, that may not. This is where, again, we have to put on our architect hat or our senior developer hat and kind of think through, does that solve the particular problem that's in front of us or not? Does that help us in this particular situation or not? And I want to stress, we don't want to be lemmings. Too often in this industry, we just sort of follow what other people are doing, and that isn't a good reason to pick a technology. Now, I would argue that FaaS is fundamentally a subset of serverless. Again, this is where we get into some of these sort of pedantic definitions. Many people do use these terms interchangeably. That's perfectly fine as far as I'm concerned. And there are some just fantastic reasons why you should use or think about using this particular approach. Sometimes it's specific to a platform. If you've got a bunch of data already with one of the public providers, let's say you've got a bunch of stuff on S3, it can be really beneficial to use functions to help you iterate through that or do some analysis on that data, et cetera. You see an awful lot of people use this to take advantage of specific functions that some of the public cloud providers give you. So a lot of people are very excited about machine learning these days, and GCP's got a pretty good variant on that. So the idea is to use functions with them to make that happen. But I want to stress, this isn't just some new way to cloud or some new cloud buzzword. There are some very serious efficiency gains to be had with a functions approach. First and foremost, the development experience is fantastic. I think back to how many Java applications I've been on where the getting started guide was like 87 pages long. And after a week or two of wading through it, you still needed a team member to come over and help you with the last few things. For about 2 years, I was like a step in some projects getting started guide. I have no idea how I became a step in their guide, but for 2 years I get these random phone calls. Hey, it says I'm supposed to call you to get my IDE set up. Can you help me with that? And of course, being a good tech person, sure, I'll help you with that. And it wasn't until like 2 years later that somebody finally, one of my friends was on the project going through the startup guide, and he said, hey, you're like step 17. Why are you step 17? I said, I have no idea. Can you remove me? He says, sure, I'll update the wiki. And so then I finally got pulled out of their setup steps. But I think about how painful it was to get started on so many of the Java projects I've worked on, and then I contrast that with a function where we're talking about 10 or 20 or 30 lines of code, something you can easily get your head wrapped around in a matter of minutes, maybe an hour or two, certainly a day at the outmost, as opposed to weeks or months in some cases with these traditional very large applications. So it allows us to be even further up that abstraction curve. It allows us to focus even more on implementation details as opposed to infrastructure details. Now I know several of us probably actually do know the operating system we're running on, but I would challenge you to say, do you really care? Is that something you should worry about? Where do you want to focus your time? More importantly, where does your business want you focusing your time? And this is where I like to talk about this notion of the value line. There's a value line in all our organizations, and we want to be above it. We want to be providing additional value that is noticed by our customers, noticed by our business partners, and so that they understand what we're bringing to the table. I don't like doing this undifferentiated heavy lifting. I would like someone else to do that for me, so that, again, I can focus on solving business problems, because that's the stuff that my customers need and want me to do. So as a developer, I would much rather focus on solving business problems than dealing with this low-level currency kind of issue that we've traditionally had to do in our industry. Now, the other side of this is resource efficiencies. One of the really powerful aspects of this function space is the fact that if your function has not been called in a period of time, we'll get rid of the container. Blow it up. You're not paying for it at that point. I think about traditionally how much underutilized hardware we've had in our industry, and it's crazy. I suspect most businesses, if they ever actually looked at their data centers and actually figured out what is our utilization number, it's probably a low single-digit number. And so we are paying for all this infrastructure, all this hardware, all this cooling of these buildings for something we're hardly ever tapping into. It's a heck of a lot better if we can just pay as we go. And so the way these environments work is a request comes in, it says, oh, wait, I don't have a container to answer this request. Let me create one for you, and away we go. So, for example, this is RIF running on my machine. And so right now I don't have a pod to handle this topic, but now one is created because a request came in on that Echo Java topic, and it says, okay, I need to respond to that, so I will create a container to do that. It'll spin up. It'll respond. Now, as more requests come in, as long as that container is created, it's just going to keep answering them. And as soon as it's seen a certain amount of time where no one has asked me any questions, there's nothing for me to do. Well, we don't need this container to just be sitting here essentially idle, wasting resources. So eventually, this will go from running to terminating. This takes a little bit of time. As it clicks through, it says, okay, that's it. Nobody has made a request on me for some number of seconds, so I will go ahead and blow this up, and then eventually that pod goes away. And again, I'm not paying for anything at that point. Now, as much as it may seem like these are free, they're not necessarily free. I mean, there is a free tier, and so all the major providers will give you 1 million or 2 million requests for free, although there's a big asterisk that comes at the end of that, which is additional fees may apply. So that there's always an asterisk there somewhere. It can be really challenging to figure out exactly how much this will cost you. And so it's important to run some real numbers in your world to figure out what this is going to look like. And 1 million may sound like a lot. It's really not. You can blow through that free tier almost overnight. And then we get charged a sort of fractional cost thereafter, which is always, again, a little difficult to understand because it's this, fractions of a penny, and I think, pi is embedded in there somewhere just to be cute. And then, of course, any additional fees we get, sort of tagged on top of that in terms of like data transfer fees or, the fees that go along with any of the other services we might tap into. But we are basically going to be charged on the number of requests we make, how long it takes to run those requests, and the amount of resources we need to execute those requests. So again, it can be really difficult to figure out exactly how much this is going to cost. And if we're not careful, our CFO comes and has a really interesting conversation with us about why our cloud bill was so expensive last month. because we made a miscalculation somewhere along the way about how cheap serverless would be for us. Now that said, for certain workloads, this is as cheap as it gets. There really is not a better way to do it. Now, it isn't just us that benefits, it's our operators that do as well. The operational efficiencies here are very impressive. Some people refer to this as serverless ops. Now, that's not entirely true, it's just we don't have to do the operations on the serverless side. It's someone else's problem. It's something else that we don't have to worry about. That's a huge win for us. We get to rely on the platform to do that for us as opposed to us having to figure that out. Now, a bunch of different use cases fit very well in the function space. Not 100% of the use cases you're going to see, of course. But typically, if we're in a situation where the business requirements are evolving very rapidly, anything that's stateless tends to work very well here. When our request pattern is very hard to predict, when it's very infrequent or it's very sporadic, we might get a bunch of requests and then it's quiet for a day or two or a week and then we get a bunch of requests. This can work out very well for us. Any situation where my scaling needs are variable, again, I don't have a very predictable curve or I don't have a very predictable notion of on this day or over this week or this month we're going to see a huge surge. It works really well for asynchronous workloads. Anything that we can easily parallelize works very nicely here. You see it an awful lot in the Internet of Things space, machine learning, log ingestion, batch processing. Works really well for batch processing. I mean, you think about kind of the traditional sort of knock on serverless is that startup experience, the cold startup can be lengthy. It can be a few seconds before it's ready to respond. It's kind of funny to me that we talk about a few seconds as being a long time. I remember when we used to think response times under 10 seconds were pretty impressive, and now we're talking about, millisecond response times. But, you think about a batch processing environment. If I'm going to roll through 1 million records and the first request takes 3 seconds, and then every subsequent request takes a fraction of a second, who cares? It's not directly affecting a human being. Now, if it's customer-facing, and 1 out of 10 of my customers is going to experience potentially a slow startup time, that might be a different question. That might not be the best place to use it. You see this in almost all the conversational UIs these days, your Alexas, your Googles, things like that, Google Homes, etc. You see it a lot in sort of the CI/CD automation space. One of the most interesting examples I saw is a company had set up an alert on like Stack Overflow, and anytime someone would ask a question about their product, it would trigger an event that would then send an alert out to a developer to go look at that question and see if they could answer it. A lot of the back-end stuff that we've traditionally done can fit in this function space very nicely. Post handling, logging, a lot of the back-end services, event processing, monitoring, alerting, security scanning. It's a really useful tool to have in our toolkit. Now, it is not the answer to every single problem we've faced. That should be obvious. Right? There are no golden hammers. I'm sorry. It'd be nice if there were. Now, we'll talk briefly here about Spring Cloud Functions before I dive into RIF. And Spring Cloud Functions, as you can probably guess from the fact that Spring is in the title, is a Spring take on functions. And one of the main goals here is to abstract away that runtime target. So don't worry about where it's going to execute. We'll figure that part out. That same code can act as an endpoint. It can act as a stream. It can act as a stream processor. We'll essentially just give you this sort of unified model, and you don't have to worry about what specific serverless provider did you want to target. And I'll be honest with you, for most of us these days, multi-cloud or poly-cloud is a huge win. It's very interesting to see how some people have already sort of decided like Amazon has like won. It's like we're still in the very early parts of this game. And I think for the vast majority of organizations, having the ability to be on multiple clouds is a huge win. Sometimes it's a tactical situation because maybe one provider doesn't have a certain feature or doesn't have it yet. Other times it's more of a strategic thing. They want to have leverage. They don't want to just have one provider that can then use the fact that, you've got a whole bunch of workloads with us, so we're going to change the terms a bit of our deal. And of course, I want to be able to run that locally too. I want to be able to run that maybe on premises. Maybe I want to run that in a FaaS if I want to. And the whole goal here is to give you choice, so that you can make the strategic decision or tactical decision that you need to make for your project in the here and the now. It also brings a lot of the Spring Boot features that you know and love to serverless. I remember the first time I got exposed to Spring Boot, I kind of thought this was cheating. Because, I've done Java long enough to remember when it's like, we got to have some XML in here somewhere. Where's the XML? This isn't hard enough. things are just working. There's very little code here. I did a little to-do app last summer just kind of for fun to play around with some Spring Boot stuff, and I had significantly more JavaScript than I had Java. I think if you would have transported me back in time, when I first started doing Java and made that assertion to me that in the future I would write applications with more JavaScript than Java, I would have laughed at you. I said, that's impossible. And yet that's the world we seem to live in now. But the beauty of this is it allows you, again, to focus on the stuff that matters, which is solving business problems. And so at its core, it utilizes a Java util function. So it uses function, consumer, and supplier. You could also use Flux if you want to. So yes, if you want to be reactive and use non-blocking I/O, knock yourself out. It also supports converting those string-based Lambda into function instances. Now, it's fair to say, well, if this is just sort of basic Java stuff, why would I want to use Spring Cloud Functions instead of something else? Well, this is inversion of control again, and part of the goal with this project is to decouple your code from the actual deployment profile. So all you need to do is add in the right dependencies, and then we'll figure out the rest. So if you want this particular chunk of code to act as a RESTful endpoint, that's fine. Just include Spring Cloud Function Web, and now it's a RESTful endpoint. Would you like that to be a stream processor instead? Well, that's okay. Just include Spring Cloud Function Stream. Now, I don't know about you, but I'm not a big fan of boilerplate code. I remember when I first was exposed to Ruby, that was a huge part of what attracted me was the fact that there was far less boilerplate. And I still remember writing a little bit of Groovy and just like a tear running down my cheek because it's like all these things I didn't have to write. It's fantastic. My poor Pinky got lazy because it didn't have to hit semicolon every single line. But I, as a developer, would much rather focus on functions and not deal with all this boilerplate stuff. Let somebody else deal with that instead. And I'd like to be able to implement this code and test this code outside of that target environment. So that's really part of the goal here, is to give you that flexibility. Now, let's turn our attentions to RIF. This is an open source functions environment. It's a recursive acronym. RIF is for functions. I think it also helps that Mark is a guitar player, so RIF, it works on multiple levels. But this is fundamentally a FaaS that lives on top of Kubernetes. So we got to throw a few more buzzwords in there because that's the nature of the beast. And the whole idea here is how do we execute functions in response to an event that comes in a way that allows developers to focus on two things: the function that you have to write, and then the topic that event is going to come into. Now, these event streams, they might be very low frequency, they might be continuous, they might be unpredictable. And so this project is built out. In fact, a lot of the guys that are working on it came right out of the Spring Cloud Streams and Dataflow projects, so it brings a lot of that knowledge to bear. One of the things that we're striving for with this project is polyglot. So we're not going to dictate what language you're going to use. Right now it supports Java, JavaScript, Shell, Go, and Python. It'd be fairly easy to add additional ones as needs for C. All this is at its core is a container running on top of K8s. That's it. And it will scale up and down as necessary. So there is a RIF function controller that watches the topic and it sees, I'm seeing some extra lag. I better spin up some additional containers so that we can respond to that more quickly. We can sort of get that back into a more reasonable amount of lag. And then eventually, I don't see anything else on this queue, so I'm going to go ahead and blow this container up. So we'll scale down to 0 after, I think, 10 seconds is the current idle time. The goal is to make as many of these knobs configurable as possible. Now, one of the things that has come out of this work is this notion of ICE. So everybody's probably heard of CAP or CAP theorem. Basically like with distributed computing, what can we control and what do we have to just accept? And so the idea is you get to manipulate 2, but not all 3. And so we kind of have the same thing here inside the serverless environment. And so the ICE acronym would be, you can be immediate, you can be consistent, you can be efficient. You get to pick 2. So the idea with RIF is to let you pick the 2 that you care about. So what is it that you're most worried about? Is it resource utilization? Is it immutable containers? Because like so many things in our space, it's all just a set of compromises. One of the things I find really ironic is you see people do a serverless environment, you see them do this functions environment, which again, part of the whole win here is if no one has called your function in a while, we go ahead and drop that container, you're paying nothing. And because people are so worried about that cold startup time, they poke their function every so often to make sure it can never terminate. I just think you're doing it wrong at that point. Because if you can't handle that, if that's not a good fit, then this probably isn't the right solution to that problem. You want to explore a different option. So if we keep our containers running, we're paying for idle resources. That might not be the best approach. Now, we can always keep a container warm and then inject our code into that container, but now we're not immutable anymore. But if I launch containers on demand, well, now I've got that slow startup experience, and that cold start can hurt. Now, you see a lot of the public platforms are using dynamic loading, and so they have sort of this pool of warm containers sitting around. A request comes in, they inject your code into one of those warm containers, they respond to that, and away we go. The goal with RIF is to say, no, you decide. You've picked the ones that make sense for you. You decide what trade-offs make the most sense for you. So your function gets packaged as a container, and then that gets run on Kubernetes, just like any other resource. So the function and the topic are just K8's resources. So they are managed via kubectl, just like a pod. They run in a pod. RIF is very thin. That's one of the things I appreciate about it. It relies on existing existing things in the Kubernetes space. It's this custom resource definition extension. This is not some special arbitrary thing. It's just a standard stock Kubernetes feature. And so again, the function controller is looking for lag on that event queue and then scales up or down as necessary on those containers. The event broker is Kafka. That is pluggable. So the idea in the future is that that'll be something you can swap in or out depending on your needs. Now, there is a RIF command line. There's a set of functions you can use. There's init, which will initialize a function. There's build, which will go ahead and create a Docker image that sits on top of the Docker CLI. Imagine that. So it's basically just calling out to the Docker CLI to build your image. The RIF apply, which says, hey, I want you to deploy this onto Kubernetes. So that's basically living on top of kubectl. And then you can use RIF create to actually do all of those together, if that's how you want to do it as well. So a lot of different options that you can play with. The invokers are now all installable resources. So when I first started playing with this back in 0.002, everything came along, whether you were using Go or Node or not. It was all there. Now you just install the ones you need. Now a lot more is done for you by Create in particular. So you can create your own Docker file if you wish. You can create your own topic or function YAML if you wish, but you can also just have that created for you via RIF create. What do you want created? RIF init. What do you want initted? And then there's various other commands you pass into it to say, this is where my function lives. This is where the Docker image I want you to use, etc. But again, this is just another inversion of control concept. Don't call us, we'll call you. Now, there is a sidecar inside of this function container that goes ahead and has the binding to the event broker, so that's the proxy pattern that's going to talk to that. There are multiple implementations of the function controller, one for every language, right? So Java, JavaScript, etc. There is only one fundamental implementation of that sidecar to talk to the event broker, and then it can communicate over HTTP, standard I/O, or gRPC. All right, so architecturally, this is what we have inside of RIF. There is an event broker, again, right now, that is Kafka, that will be pluggable in the future. We have the function pod. Inside the function pod is our function container. The container contains an invoker. It also contains our function. This is the only part of this that we are directly responsible for. We write the function. Everything else comes along with RIF. There is a sidecar container. Inside the sidecar container is a dispatcher, and there's also a binder. And this is how we fundamentally talk to the event broker. So there's a broker API, and again, it's the sidecar that's responsible for that. And then the sidecar just passes that information back and forth to the function container over HTTP, gRPC, or standard I/O. Another way of looking at this from a technology perspective, we've got Kubernetes sitting at the core of this. There's also Kafka. And this is usually the point in the talk where the power goes out. I'm not entirely sure why that is. I think it's got something to do with Kafka. If I say Kafka enough, apparently that's enough to bring down the power. Kafka is talking to an HTTP gateway. We have a set of controllers. There's a function controller and a topic controller. They're talking to Kubernetes. Kubernetes is managing them. We bring a little bit of YAML to the party that describes our function, describes our topics. And then we have a set of pods that contain our functions. And then they're talking to Kafka over that sidecar and then executing as necessary. All right, now again, this is a very new, very evolving space, but the goal here is to give us an agnostic layer of FaaS that allows you to run this wherever you want, whether that's on premises, whether that's in this cloud or that cloud, give you the options to run it where it makes sense for you. So let's dive a little deeper into the moving parts here. So we have Kubernetes. Can't swing a dry erase marker in an enterprise these days without running into somebody who's very excited about Kubernetes. Its job is just to scale and manage your containers. Now this comes from Google, and so it's built on the lessons learned at Google. Needless to say, this is not their first rodeo. They have learned a thing or two about how to do this and do this well at scale. It's stunning to me the scale that some of these organizations work at and the kinds of things they run into at like Tuesday at 2 o'clock. Many of us would like never see in our career. So it's something to keep in mind that these folks know what they're doing. They have good experience here. And it does a lot of what you would expect out of this kind of capability, right? So it's got self-healing, it's got scaling, it's got service discovery, load balancing, et cetera. It'll help you with automated rollouts, rollbacks. And at the level we typically work at, it'd be the kube cuddle. Now, depending on who you ask, this is pronounced different ways. I've had some people insist to me, no, it's kube control. Others say, well, I always spell it out, kube CTL. Some people say it's kube cuddle. That's usually what I use. Some people say, no, it's a harder letter, it's kube cuttle. It doesn't matter. Whatever works for you is perfectly fine. It's the command line interface. The beauty of Kubernetes is you say, this is what I would like. I need this many containers, this many instances, et cetera. You go ahead and figure it out. And then Kubernetes says, okay, fine. You said you wanted 4 app instances. I see there's only 3. Let me spin up a new one and get that added into the pool. And so insert your favorite Captain Picard reference here. There are a number of abstractions that you hear about in this space. There's pod, service, volume, namespace, et cetera. You've already heard me throw pod out a few times here today. A pod is just a thing that houses a container. A lot of times it's a one-to-one. A pod has one container. It doesn't have to be. It could be multiple containers. This is also where storage and unique IPs comes from. But this is the fundamental unit of deployment in Kubernetes land. You can think about it quite simply as an instance of your application. Now, this is often a Docker container. It does not have to be. It does support other abstractions as well. And while it is most common to see one container per pod, it is possible to have multiple containers, and some of these are very tightly coupled. Now, I do think it's a little interesting when people say, oh, these microservices all deploy together. It's like, those might not be microservices anymore, depending on how we want to define that term. But the beauty of a pod is that I can share those resources. So that's part of why you see this abstraction come up of having a couple of containers in the pod, because now they can talk directly to one another. They don't have to go outside and come back in as they typically do in some of the other platforms. Now, these helper pods are almost always, or helper containers are almost always referred to as a sidecar. So we have Docker as well. Everyone gets very excited about Docker these days. Now, Docker is quite simply just a box. It sort of builds on that shipping container concept. If you think about the way shipping used to be done, it was a very labor-intensive. You needed a whole bunch of people to carry things on and off the ship. And then someone said, hey, let's all put it in a uniform box. And then we'll have a crane lift the box onto the ship, lift it on and off, and it just puts it on the back of a trailer, and now it's the same size as a typical semi-trailer, and away we go. And so all you got to do is put things in and out of the box. Makes it a lot simpler, a lot less labor's involved. And you can put whatever you want in there. As long as it fits, it ships. I have a similar analogy for my cats. My cats have this attitude that if they fit, they sit. Whether that's like in a box or whether that's on my laptop, it's all good. One of my cats loves to pair with me, but he gets very annoyed that I need my hands on like the keyboard, and so he'll like lay across my arms as I'm trying to type, makes it very difficult. And then he gets very annoyed at me when I try to move him. He's like, dude, I was sleeping here. You put whatever you want in the box, everything it needs to run, your code, your system libraries, the executables, et cetera. And the beauty of this, and the reason why a lot of us get very excited about it, is the fact that my code is completely isolated from the environment. And then I think back to how many times in my career I have wasted effort, energy, and time on issues where it worked in this environment, but not in that one. Well, it worked in dev, why isn't it working in test? I don't know. The worst instance of this I ever personally experienced, it worked in one region and not another, and the only difference between the two regions was the order the patches were applied. Otherwise, they were identical. And that was just enough of a difference to make sure that our stuff ran in one and not the other. So instead of copying our code from one instance of an app server to another instance of an app server, just pick the whole thing up and move it. Right? So that's the beauty of these containers. Right? Just define everything you need, and it's very similar in concept to a virtual machine. It's just what level are we virtualizing at? So instead of virtualizing at the hardware level with a typical virtual machine, you get an image, and it's just a box. You log into it. As far as you're concerned, it's a standalone server. It's not, but that's the way it appears to you. Same concept, except now it's at the operating system level. Now, the challenge with Docker that a lot of people don't really take account for is that you have to tell Docker everything you need. You are the one who's responsible for maintaining that image. Do not underestimate the effort it takes to maintain an image. Now, it's typically going to be stored in some kind of a registry like Docker Hub, or maybe you've got something on-prem, and you've got these images which are templates or recipes for building other containers. Now, typically, we do go ahead and customize existing images, but still, we are responsible for that customization. We are responsible for maintaining that over time. When new versions come out, if we need things to get updated, we have to rebuild those images. And that actually works out fairly well in many cases, as long as we are aware of that trade-off. Now, the thing I always like to stress when we're given this kind of power is that there is responsibility that comes along with it. So to paraphrase Uncle Ben, with great power comes great responsibility. So please make sure you stay current. Now, certainly as a U.S. citizen, one of the things that I am unfortunately very acquainted with is the Equifax hack. Right? This got a lot of attention last year, rightfully so, because virtually every U.S. adult has had their information now spewed across the dark web, thanks to them running an unpatched version of struts. Now, it's unclear to me at this point which is the bigger crime here, the fact that they were running an unpatched version of struts in production in 2017, or the fact that they were running struts in 2017. I'm willing to have that debate. But it's not just limited to that. I mean, everybody at this point has heard about Meltdown, they've heard about Spectre, and of course, if you want the good definition of what those are, go check XKCD. As always, he does a fantastic job of actually explaining this to you. In the instance of time, I'll leave this as an exercise for you to track down later. But it's important that we understand the implications of staying current. And then, of course, we have Kafka. Kafka is the distributed streaming platform. It's basically a message queue with pub sub and gives us kind of the best of both worlds. Does a really good job with that. Gives us this real-time stream processing. All our records live on this topic. And they've got a key, they've got a value, and then there's a timestamp. Now, what makes Kafka very powerful is the fact that it knows how to partition these topics. They're ordered, they're immutable, everything has an offset. And so different consumers can be working at different parts of the queue. And based on your retention settings, those are kept for as long as you need them to be kept, and then consumers can just come and go, and they can pick up wherever they need to. Right? So that allows our consumers to go back in time, reprocess things, skip forward in time, et cetera. And so fundamentally, Kafka is the best of pub sub and queues at the same time. It's really interesting to see this shift in our industry from the database is fundamentally the source of truth to our events are fundamentally the source of truth. And the database is a snapshot of those events over time. I made that comment earlier this year, and someone said, well, you do realize Kafka is storing things in a database. It's like, okay, fine. There's always databases somewhere. But it's just a change in how we approach that I think is very fascinating to see. All right, so we get this ability to split things across multiple consumers. It's a very, very powerful abstraction, to say the least. There's a reason why a lot of people are very excited about Kafka. All right, so what does this actually look like trying to use it? Well, you write a function. A little bit of code, a little bit of Java, a little bit of JavaScript. You need a Docker file, and then you need a little bit of YAML to configure this together. And a lot of it we don't even need to write directly. I'll show you kind of an old version of this, but it gets us to the same place. So, hello world, if I just wanted to go ahead and echo back, this happens to be a little bit of JavaScript. So we'll echo back whatever you happen to type in saying, I'm echoing this back to you. All right, so I need a container. So I need to say, all right, where is this coming from? I'm going to use the node invoker. All right, so this happens to be a slightly older version, doesn't really matter, same basic concept. So go get me the node invoker Docker image. I'm going to customize from there. I'm going to be injecting a function into this. And then, by the way, the name of my function is whatever the name of my function happens to be. In this case, it's echo node. And so that will go ahead and get replaced in that environment variable up above. So there's my very simple little Docker file. Then I need that RIF invoker is living out on Docker Hub, imagine that. We set up this environment variable that says, here's where you should find my code, and then our function gets injected into that image. All right, so wherever at that directory that gets named there, that environment variable gets replaced with the name of our function. Now we need to configure the function and the topic. Now again, you don't even need to write this anymore. This can all get generated for you, but this is the basic idea. This could be split into two separate files if you want. It doesn't have to be in one. I kind of go back and forth as to which is simpler. Notice that we have two different things in here. We've got a topic and we have a function. And so the topic, we're going to call it, in this case, happens to be echo node topic. I'm not very good at naming things. Now notice that has to match the name on the function that says, where's my input coming from? Oh, it's coming from this echo node topic. So if those two names aren't the same, it's not going to work. Because the topic gets called one thing, that's where the function expects to find it. And then what image am I using? Well, I'm going to use this echo node image thing I just created. So this maps back to that Docker file we just created. And then all I have to do is build that. And so I say, all right, riff build what? Well, this echo node, there's the version, et cetera. Again, a lot of this is just sort of sitting on top of other CLIs. But it goes ahead and says, all right, let's roll through. I'm going to grab that base image. I'm going to create this environment variable. And then I'm going to add your function into this container. And away we go. All right, so now we get this nice little image based on our function as well as whatever's coming from that parent image. And again, you can do this all direct with a Docker CLI if you wish, because essentially what it's doing is farming out to Docker build and Docker push. And we say, okay, I'd like this to run. And so we say, okay, make this so K8s. And so if I do riff apply, it'll go ahead and actually put that out onto Kubernetes. Kubernetes will spin that up, and then eventually I get something that looks a little bit like this. There's an awful lot running here, but you can see that we've got that echo node. We've got the topic gets created, and then once a request comes in on that topic, it'll go ahead and spin up a container to respond to that particular message. And again, I can do this all in kubectl if I wish. I can just use the RIF CLI to sort of paper over a lot of that. It's totally up to me. You can kind of go back and forth, whatever makes the most sense for you. And again, this is all just a wrapper over kubectl. And so it's calling kubectl apply. And then we can execute our function. And so I can go into a command line, I can run a curl or an HTTP against it, and then eventually what's fundamentally going to happen is it will echo back saying, okay, here, RIF is for functions, isn't that nice? And under the covers, of course, what it's doing is it's watching that container. When it sees an instance, or when it sees that request come in the topic, an instance spins up, and it's going to go ahead and respond to that. And then once there hasn't been a request over a period of 10 or 15 seconds, it goes ahead and terminates that container, and again, frees up those resources for me to use elsewhere. So that is the beauty of RIF. And by the way, this runs on public containers as well. This doesn't have to run just on your laptop. This doesn't just run on premises. You can load this all into GKE, and it will run there as well. And so rinse, repeat. Now, I think the real challenge for us in all of these situations is figuring out what makes the most sense for us. What approach should we use? Now, the longer I do this, the more convinced I am that there are 3 answers that work for everything in computer science. There's 42. That's to see who's read The Hitchhiker's Guide to the Galaxy. Another layer of indirection. That's my favorite pattern as an architect. And of course, the answer that I use almost all the time is, it depends. Right? Now, I realize that that's a bit of a cop-out, and I've had some people get very mad at me when I say it depends. It's not the end of the conversation, by the way. It's the beginning of the conversation. And so if someone like me says to you, it depends, your response should be, what does it depend on? And then we should have a conversation about that. So there is no one magic answer in the cloud space. And to steal this directly from Anzi, it's an and, not an or conversation. We need to look at these as having specific solutions to specific problems, and some are well suited to solve those problems and some aren't. So not every workload is going to fit in every single bucket. You cannot take a traditional application and say everything's a function. That way lies madness. Right? Are there certain aspects of your current applications that would fit very nicely in a function? Absolutely. But the challenge for us is understanding the trade-offs here. There's always trade-offs. That's the nature of design, that's the nature of architecture, is balancing those trade-offs and understanding what tension am I trying to solve here. And again, to go back to Uncle Ben, with great powers come great responsibility. So I need to ask myself, what's the most important part of this? How do I feel about development complexity? Do I want my developers worried about operating system level patches? Or would I rather have them just pushing apps? I think back to a lot of the issues I've had as an architect in my career, and it's because a developer decides to go rogue and just do whatever they want. And there are instances where having these guardrails, these constraints, is actually very freeing. I remember hearing Dave Thomas talk about Rails when it first came out, saying how he really bristled against the sort of file structure that it imposed. And for the first couple of weeks, he said he really didn't like that, and he felt it was this constraint. How dare you tell me where to put my code? And then after a couple of weeks, he realized, well, it's just an opinionated way of doing it, and it turns out I actually agree with most of those opinions, so it's fine. It doesn't make that fundamental a difference in our world. It's not like tabs versus spaces. That's a much different argument to be had. But there's also operational efficiencies here. We have to ask ourselves, how many operators does it take to manage these bespoke environments, and is that where we want to spend our resources? We need to understand the trade-offs between flexibility and standardization. And we need to also remember that guardrails aren't shackles. I remember my honeymoon, my wife and I went to Greece, and we were kind of in this bus going along these various sort of switchbacky kind of roads, and I remember thinking, there's no guardrail here. I sure hope the bus driver does a good job, because it's a long way down that cliff. And I don't think the bus is going to handle that very well. So you understand after a while that these things are designed to protect you. And so take a step back and ask yourself, where do you want to allocate your resources? And then choose the option that best fits the problems that you're experiencing. Again, I'm adamantly of the opinion that we want to push as many of these workloads as high up the abstraction tree as possible. We also need to understand this is a heavily evolving space. And, to paraphrase Ferris Bueller, functions are moving pretty fast. RIF in particular is very, very new. Now, hopefully I've whetted your appetite, and you'll go and explore this, and you'll play around with Project RIF, or you'll try Serverless Spring. I would encourage you to do that. RIF is for functions. There's a lot of fun stuff here. There's actually a pretty good presentation on this by one of my colleagues as well, if you want to get a little different perspective on it. Sadly, I am out of time for questions, but I will be floating around today if anybody has anything they want to talk about. Thank you so much for your time and attention today. I really appreciate it. Cheers.